Today we're going to be learning about our final last two rules of exponents, and we're going to look at negative and zero exponents. Our picture to start us out is one of my favorite paintings. I have seen this one in person. It hangs in the Smithsonian in Washington, D.C., and it's by William Michael Hartnett, and it's called The Old Violin. And this is one of the few paintings in the Smithsonian that actually hangs behind a panel of glass, and that's because it looks so realistic. Even when you're face to face with it, people were going up and trying to pluck the strings because it looked so lifelike. People thought it was a real instrument. And so because it was getting damaged right here around where the strings were, they covered it with glass so people would stop touching it. We're going to start out by looking at this table here, and we are going to minimize this table just a bit, and we're going to look at one piece at a time. So for this first part, we've got 2 cubed. 2 cubed is 2 times 2 times 2, which is 8. And then we come over here, we've got 8 divided by 2. Well, 8 divided by 2 is 4. So I put that 4 right there. So now we have 2 squared, which is 4. 4 divided by 2 is 2. So that 2 is going to go right here. And then we have 2 divided by 2 is not 2. 2 divided by 2 is 1. So if we look, this number here when we divide is going to be our next value for whatever the term is over here. So here, 2 divided by 2 is 1, which means 2 to the 0 power is 1. That's something that is going to be one of our rules we're going to look at in a few minutes, and it's just something you kind of have to accept. It's a little hard to wrap your brain around. The only way we can really explain it with your math knowledge so far is that it fits the pattern. Same thing would work if we had 5s. 5 cubed is 125 divided by 5. 5 squared is 25 divided by 5 is 5. 5 divided by 5 is 1. And so 5 to the 0 power is also 1. Anything at all to the 0 power is going to give us a value of 1. Now let's look at what happens when we go into our negatives. When I've got 1 divided by 2, well, 1 divided by 2 is half. Half divided by 2, if I have half a candy bar and I divide that in half, well, half of a half is a fourth. If I have a fourth and I'm cutting that in half, well, half of a fourth is an eighth. So 2 to the negative third is an eighth. And then if I wanted to go to the next level, half of an eighth is going to be a 16th. So now let's look at how these patterns show up. Here I've got 2 to the third power. When I have 2 to the third, that gives me 8. When I have 2 to the negative third, I no longer have 8, but I still have an 8 involved. It becomes 1 over 8. If I have 2 to the second power, 2 to the second power is 4. 2 to the negative second power is 1 over 4. Same thing with that first power. 2 to the first power is 2. 2 to the negative first power is 1 over 2. So that's going to be our first rule for today. Anytime you have a negative exponent, it becomes 1 over the positive exponent. Anytime you have a negative exponent, it's 1 over the positive exponent. So if we're going to write 5 to the negative second without a negative exponent, we can write that as 1 over 5 to the positive second power. You can leave it that way depending on the problem. I'm fine with you leaving it that way most of the time. Or you can also say that, well, 5 squared is 5 times 5, or 25. So that would also be equivalent to 1 over 25. Let's look at this in action. Here, example 2, we're simplifying this without a negative exponent. Now remember, as we've discussed in class, your exponent points to what's directly in front of it. And what's directly in front of that negative 3 is just the y. So our 2 is going to stay where it is. The y to get it to be a positive 3 is going to go into the denominator. So that's 2 over y to the positive third power. Give this one a try. We've got 6x to the negative 7th. Pause your video, try this problem, and restart once you think you have the answer. If you got 6 over x to the positive 7th power, give yourself a heart. If you did not, give yourself an X, go back and look at the last example, retry afterwards. Put a circle around your X once you figured out your mistake. Let's look at this one. Here I've got 6x to the negative 10th times x to the second. I'm going to use my first exponent rule that we talked about several days ago. I'm going to combine these two exponents. So I've got negative 10 and 2. I'm multiplying those bases, so I'm going to add those together. So that's 6x to the negative 8th power. Again, I've got my negative 8 only pointing to my x. So that's going to give me 6 over x to the positive 8th power. Let's try this next problem on your own. We've got 7y to the negative 3rd, y to the negative 5th. Pause your video, try it on your own, and restart once you think you have the answer. If you got 7 over y to the 8th, give yourself a star. If you didn't, put an X on your paper. Go back, rewatch the work from the last problem, and try again. Once you figure out your mistake, put a circle around it. This is a problem that there's a lot of behind the scenes going on. You don't have to write this whole thing down right now, just watch what's going to happen. There's kind of some behind the scenes math magic. So here when I've got that negative 3, we're going to use that rule number 3 that we've talked about, and I'm going to distribute. So that's 2 to the negative 3rd power over 3 to the negative 3rd. Well, now we can't leave negative exponents. That's wrong. We can't do that. So I'm going to make this 1 over 2 cubed and 1 over 3 cubed. Well, just as it's bad to leave negative exponents, it's really bad to leave fractions inside of fractions. So I'm going to rewrite this as, well, this line right here, this fraction bar, just means division. So I've got 1 divided by 2 to the 3rd divided by 1 over 3 to the 3rd. Well, we've got to make that look a little bit nicer. Remember, when you are dividing fractions, you can Kansas City football, Kansas City fails, depending on your allegiance. We can keep, change, flip. So we can keep the first fraction the way it is. So 1 over 2 cubed. Sorry, my 3's are looking kind of funky. Change from division to multiplication and flip this second fraction over. So that's going to become 3 cubed over 1. From here, we're going to multiply straight across. So 1 times 3 cubed is just 3 cubed. 1 times 2 cubed is 2 cubed. And that's going to be our final answer. Now look how easy it is to go from the original problem down to this final answer. All you have to do is distribute and flip. So if I had a problem like, let's say we've got 3 to the let's say 3 to the 1st over 2 to the 7th. I don't want to draw another 3. And all of that is raised to the negative 4th power. All I have to do is flip the insides. So I'm going to put my 2 in the numerator and my 3 in the denominator and distribute. So I can ignore the signs now. 4 times 1 is 4 for that 3. 4 times 7 is 28. So all of this gobbledygook in here is the behind the scenes of why it works. But you don't have to write any of that down. You just need to say, you can go directly from the original problem to the answer if you have one like that. Our last rule is for zero exponents. We saw this in the example of that table there. Anything at all to the 0 power is 1. So if I've got this giant thing, 3 to the 7th times 3 to the negative 10th, all to the 0 power, those are beautiful, wonderful, amazing problems because all that happens is that it turns into a big fat 1. And no, you cannot just say, well, I'm going to take this entire equation and put it to the 0 power to make it turn into 1. Doesn't quite work that way, but nice try. Let's look at this one, example 5. I think this might be example 4. The 0 only points to what's directly in front, and what's directly in front is the x. So that means this is really the same as 5 times 1 over 3. Well, 5 times 1 is just 5. So this turns into 5/3. Give this problem a try. 7 to the 0 power times x to the 8th power. Pause your video and replay once you think you have the answer. Did you get x to the 8th power? If you did, draw an up arrow. If you didn't, put an X on your paper, go back and figure out your mistake, and circle your X when you've got the correct answer. This one right here, we don't have an additional problem for you to try with this one, but this is another way to illustrate that anything to the 0 power is 1. So if we think about this, this kind of goes back to that rule that we had earlier, where when you have the same base, you subtract. So that's 3 to the negative 2 minus negative 2 power. We'll leave change opposite. That's negative 2 plus 2. Well, negative 2 plus 2 is 0. So that's 3 to the 0 power there. We also talked about how when you have anything divided by itself, it's 1. So 5 divided by 5, 57,983 divided by 57,983, x divided by x, 3 to the negative second over 3 to the negative second. Anything divided by itself is still 1. So that's another way to kind of try and wrap your head around why anything to the 0 power is 1. You have 4 homework problems tonight. Ignore the big red blob. I decided not to give that one to you. So take your time, do your best, and we'll discuss it tomorrow. Have a great day.